So hey everyone, welcome to our talk, What's New with Private AI Foundation with NVIDIA. My name is Ala Dewberry. I am the product manager for Private AI Foundation, which as you all know is going to be included in VCF going forward, so yay.
Yeah.
And I'll let my fellow speakers introduce themselves too.
Go ahead.
Sure. Hey all, my name is Ash. My name is Aish Nair. I am a product manager on NVIDIA's AI infrastructure team and super excited to be here.
I'm Rama Dwarha. I'm the Director of Systems and Operations with UT System. That's University of Texas System. Thank you.
Yeah. And before we dive into it, our goal for the talk here for the next 30 to 45 minutes that we have here today is to really show you the art of the possible in terms of VCF and GenAI. So with that, I'm going to hand it over to Rama, who has done an incredible job with his team in rolling out their private AI practice across several University of Texas campuses in a really highly available multi-tenant fashion. And I will hand this
thank
to you.
Well, I guess we better get through the disclaimer, even though I'm not with Broadcom.
We should make a chatbot for that.
Yeah, she's going to do that next year, and we won't have to worry about dealing with it as on the screen. So everything I say, it might not be against these disclaimers. All right, let's get started. I want to give a quick intro about who we are, what we're doing, and we'll get into the presentation right away. University of Texas System has about overall 14 institutions, and that includes 9 academic centers and 4 health science centers and the system office. That's how we get to that number. And the shared services team runs anything that is shared with more than one campus. It can be part of a shared service. We have everything from ERP systems to enterprise contracts, Microsoft services, lots of shared services like that. And what we're going to be talking about today is AI as a shared service in a multi-tenant environment. This is pretty exciting because I'll get into our journey here shortly. And we're going to start with, in higher education, typically you have healthcare, you have students, you have research, you have administrative use, you have professors who are going to use it, and these all amount to a large number of use cases. But we're going to start with a few small ones. For the research side, we're creating like AI institutes, and they will figure out how to prioritize what projects are coming in that are AI related. We have an exciting POC that's going on right now. It's called the AI Tutor. If you grew up, went to college, university, you had a teaching assistant. Now your TA is going to be a virtual AI tutor. And we have about 14 classes today that we're uploading into that. And those professors are going to be fine-tuning and getting it going. So it's a pretty exciting project. We'll talk a little more about other things in the pipeline shortly. But I do want to let you know that we didn't get here overnight, and neither are you if you get on this journey. By the way, quick show of hands, how many of you are doing some kind of private AI? No, on-premise? Yeah, oh, that's good. And AI in the cloud, probably a large, anyone? Show of hands. If not, I think this is a good journey map. So we started out with proof of concepts. And the way that works is we had a high-performance computing center. We went to them, got 2 GPUs, and that's how small it was when I started out. Since then, we've gotten our hardware in, done our own setup initially, and we'll talk about what the setup is. And then we went through getting the AI environment ready, then getting use cases. But prior to that, we focused heavily on just GenAI. And that's primarily what this journey was initially. So that includes chat, RAG, and inferencing, to keep it simple. So let's get into some of the current project statuses. We have about a few more than this, but overall what we're looking at is a 9-institution journey where each one is doing something or the other. Anything from AI chatbots to HR training documents to employee benefits analysis. And the legal team could be doing analysis for what they were using a paralegal for. So all of those are part of these, and I've only listed a few in here just to keep the slide from getting dense. Right? So this is probably the next few slides where we're going to get into the meat of our discussion. This is the framework we've used. Jason, who's part of my team here, he's here. Thank you very much for putting this together. And I'm going to talk through quickly what's in place here. So it starts with infrastructure as a service, which we already do in our shared services. So we built on top of that, and that was one of the main reasons why we chose VMware's Private AI Foundation to build on. Within that, what you see in the pink is essentially all VMware Private AI Foundation plus VCF, which is now all going to be rolled into one package, as you heard today. So there is probably some reward for you guys for waiting, because you didn't have to pay for it separately. And you know they're not giving your money back. So, and then you'll get into seeing how we're using NVIDIA as part of this as well. And I'll discuss a little bit about the whole setup. But apart from that, I would ask you to think about additional things you need to put in place, like how to evaluate a model when it comes in, security, monitoring, all those things. So we started with infrastructure, and we decided in shared services, we are going to be more of a platform as a service, okay? Everything in AI platforms. Once we get above the platform, you're getting into the orchestration, automation layers. And within that, one of the key things you need to put in place, and we're working on, is the AI gateway. It would simply be like an API gateway, so you're not having to build custom bolt-ons into everything. In the data layer, this is for every project that we do. Additional data that brings in, we create pipelines, vector databases, and it is this would be complex to manage without the VMware solution. Right? I'm just going to call it PAFE for now, so we all understand it's a simple way to refer to it. Moving on, we'll talk about how the models are stored in the next few slides, but I wanted to touch on a little bit of the OpenAI, Open Web UI solution that will give you the feel of OpenAI or ChatGPT, an interface. You need a portal, and that does not come with the solution, so you'll have to go and find one. There are many open source ones. Within this, we have rankers, re-rankers, all those solutions are in this model. So I would ask you to think of starting out with, what is your framework? Build something simple like this that you can explain to your team members, right? And we started this out with a team of 3, and they were already existing VMware staff. So you see how just extending their skills, you can get started on this. And by the way, we'll try to go through it fairly quickly so you can ask any questions you have towards the end related to it. Let's get into what our multi-tenant environment looks like, right? You saw the framework. Now we're getting into the details of how that's set up. Everything on the right side as you face it, that is what is included in the shared services that we provide. Within this, you will see Harbor is used to bring in all the LLMs, and you can store it there. And currently we have 4 of them, and it includes Mistral, Llama, the 11 billion version, and the 90 billion. So it's on 3.2. We're waiting to go to 4 here pretty soon. And we also have Nemotron, and I'll show you how it's all laid out shortly. So the way we envision this is you'll have productivity tools like Copilot, other things. That's not what this addresses, okay? Those AI solutions are going to address your day-to-day things. This is more of a private AI where you're addressing GenAI uses and specific business use cases. So for general purpose, anyone can come in, and the beauty of this is we don't count tokens, so they can use it. How many of you know what a word and a token is? Can you translate? Can you tell me an apple is 1 token and a banana is 1, or are you confused what that is? On average, in the sizing that we've done, yesterday there was a good presentation on that. Alex from VMware conducted it. 1.5 tokens to a word is a good approximate translation, okay, for planning purposes. We're not going for accounting accuracy here, so it's a good planning number. And the reason we chose this way is if we were to choose a cloud solution, we have to have a token limitation, or Microsoft sells it as PTUs. You aggregate them and it amounts to X number of tokens, right? So in ours, we're able to show the token usage using VMware solutions, but we're not getting into restricting your use. So we have a general AI where people can come in. Obviously, you got to work out your authentication, access, authorization, all of that. If you're we're mostly on Microsoft Entra, so it's pretty simple. We connect, we get in. Move to the next level, we have a development and a production for any products that are developed, right? So this team, I would advise you to have at least a couple of developers, a full stack person, AI, ML person. You don't need all of them full time, but you need them to manage this kind of a solution, right? Outside of your VMware team to manage that. So our campus users come in, authorized only to do development, then they'll move it to production with the help of the VMware team, internal team, and then we will publish that. That's how it works. So this would be if you think of yourselves in 10 departments, each one will have to bring their stuff, get their data organized. All of them have to be brought in. If you're building AI agents, this is essentially the foundation of how that would work. Okay, moving on to the next slide. This is the place I'm going to talk a little bit about. We have 4 servers without any GPUs to have a management stack. And then we have 3 other servers, 3 AI servers. Currently, they run H100s, 4 GPUs in each of them, right? So there are 12. And we've also added, not in the picture, here soon, 8 more GPUs with the new NVIDIA H200s. And what we're going to do with that, hopefully, is upgrade and increase the number of LLMs that we can bring in. That's primarily the reason we're bringing it. So the idea is once you put this basic foundation, all you're doing is scaling up the GPUs, okay? So we're going to add 8 at a time, and 4 of them will be bridged. If you look at it, the beauty of VMware's PAVE solution, you can do microsegmentation. Where we're doing it is we take 1 GPU and go 1/10 across the board, okay? So as we allocated, you're at least getting 1/10, and we're not wasting giving you extra GPUs that you don't need. If you look at the entire solution, Llama takes about 4 of those GPUs. On top of that, we have Nemotron. NVIDIA is taking 2 of those. Then we have smaller language models taking 1. And extra models that come in, Ala's going to cover this where you can see you can have a repository in Harbor and bring it in only when you need to use it. So it's not like they're consuming GPUs if they're sitting there. So with this, I'm going to turn it over to Ala, and she's the star of the show and has all the details you need to make this work.
I don't know about that, but yeah. So thanks, Rama, for that overview of how you've just done an amazing job just deploying everything across all your campuses. So let me talk a little bit about why VMware started this AI journey a few years back. So back in 5.2, we saw this trend, just that AI was kind of eating the world. And as lots of different market studies show, AI and GenAI specifically is going to be an integral part of how different businesses operate, including higher education. So yeah, our goal here is to just make AI workloads another workload on VCF, on your infrastructure. So, over the past 30 years, we've gone on the journey from bare metal to virtualization. In recent years, we have added containers, really a robust container solution to that with our VKS, new name, our VMware Kubernetes service. And the great news about that is AI workloads, whether it's inferencing or training or fine-tuning, all of that stuff runs in containers. So this, our VCF infrastructure is well positioned to, again, just make this basically a set of Ubuntu VMs for all of you. So yeah, when it comes to making this real, it comes down to delivering on a few key promises. So first is privacy and security. There may be use cases for GenAI in the public cloud that you might have. That's totally fine. It doesn't need to be an either or thing. But for the use cases that have data that's, either it would be costly to move it to the cloud, or it's just too sensitive to move to the cloud. This is where private AI makes a lot of sense. Now, an equivalent for us here at VMware, that would be something like our ESXi kernel code. That's just never going to leave our data centers or ever go to the cloud. So if and when we want to do something like that, we're going to build our own solution on top of VCF. The next is that it has to be simple. So in terms of, from a multi-tenancy angle, giving all of you lots of options in terms of how you want to carve up your GPU infrastructure to your lines of business, to your various teams is really important for us to deliver on. So whether it's, you have lines of business who really insist on having, their own physical infrastructure, they want their own dedicated clusters, we can handle that. Or if you're more comfortable with a thin tenancy model where you can have, a shared pool of GPU clusters even globally. So if you have global teams, one of those teams in Singapore go to bed at night, they're done with their work for the day, or the chat app that they're using is sort of done for the day, but then your teams in Europe and the Americas come online. How can we have, sort of a workload allocation model that can also function from that perspective? And then in terms of streamlining model deployment, so this might sound niche and kind of specific to mention, but at the end of the day, GenAI is all about these models. So how are we giving you choices on what models best suit your development team's use cases? Do you have proprietary models that your teams have trained? I've heard a lot about manufacturing use cases for, if you're making a specific car, a model on a manufacturing line, we'll be looking at that specific, car door. And when you move to the next, car model, the door is going to look a little different. So you got to retrain that model. How are we making it easy for you to make those changes? What if you want to use a Mistral model? What if you want to use one of the Llama models from Meta? Again, our job is to make that choice as easy as possible to execute securely on our platform. So let me just do a really quick recap of Retrieval Augmented Generation architecture. So this is a simple but very powerful generative AI architectural pattern that we have delivered services for with our private AI services in VCF 9.0. So the message here is that you can, as a service, offer the capabilities to build these applications on VCF, and this is just included. So step one is you've got to put your proprietary data in the vector database. So this is something that we provision using Data Services Manager, and this specific capability of Data Services Manager will be included as part of the AI capabilities. So in terms of how this application actually functions, the user will come to their chat interface, like, their ChatGPT-like experience, and they'll type in a question. This could be a question about, maybe it's an HR chatbot, what's our vacation policy, or how do I sign up for dental insurance? Or it could be really important questions like, what is the airspeed velocity of an unladen swallow? So I know all of our organizations are, yes, okay, good, I got some laughs. Are deeply invested in this question. And so you might have proprietary data around the physics of this question. So step one is that this prompt or this question goes to the query encoder. So the query encoder is actually a small ML model that assigns a vector embedding to this sentence. So it's kind of like a decimal number that kind of looks like the latter part of pi. And all it is a numerical representation of meaning. So it would look, there would be, a vector for the word swallow. And swallow is actually an interesting case because it could be what happens after you chew, or it could be a bird. So the vector embedding for each of those meanings is different, and this embeddings model is smart enough to figure out, are we talking about eating and chewing, or are we talking about birds? So once we've gotten that assignment, the query goes to the vector database, and this process called similarity search happens. So this is step number 3. So the vector of the sentence is compared to the vectors of the documents in your vector database. So it's just this really simple matching that's done between that sentence and the documents, so that we make sure that we're getting the most relevant documents to this very, very important question. Oh my God.
There you go.
Whew, quick recovery. All right, so once we've done that retrieval process, we send the question and these documents or paragraphs that we've retrieved from the vector database to the LLM. So this is important because, the LLM, when it comes to enterprise data, hasn't been trained on any of that. So if we're using one of the Llama models, for example, it hasn't seen your enterprise's proprietary data. Fingers crossed, unless you're about to find out that there's been some huge security leak. So this is, again, just a really powerful but simple way to avoid having to train or fine-tune a model, but still expose it to your proprietary information. So with that, the LLM reads the question, looks at all this information that you've given it, and generates a response that's going to be more accurate and more informative because you have exposed it to your enterprise's proprietary data. So our capabilities in 9.0 that are again included in VCF are fourfold to deliver this architecture. So first is that model store. So this is just Harbor running in the background. This is just a repository where you can store models as OCI artifacts on your private infrastructure. And again, this could be homegrown models. It could be any possible model you want from Hugging Face or from NVIDIA NGC, anything that you want. And Harbor is really great from a governance perspective because it has really robust multi-tenancy and RBAC. And as we know, once you've done the work of vetting the model or if you have fine-tuned it, you really want to make sure that the right teams have access to it. And especially with fine-tuning, that model is now an extension of your data. So if you've put proprietary finance information or something, that's not something that you want the marketing team to see. So again, RBAC and governance becomes very important. So when you're ready to actually run the model, this is where our model runtime and API gateway comes into play. So our model runtime allows you to take the model weights that you have in Harbor and to deploy it on an inferencing server. We use VLLM, very common, open source inferencing server for LLMs or completions models. And we use Infinity for embeddings models, which is the model that helps you process your data. Now, the data indexing and retrieval service is what's going to take your proprietary data and really put it to work. So we allow you to connect to a couple of different sources of data, on-prem Confluence, on-prem SharePoint, S3 buckets, or any S3 compatible storage you have, and also Google Drive. So again, all those HR PDFs, those, finance documents that you want to use to create your initial chatbots, those you can, using this service, we will put it in the vector database for you, clean it, chunk it, take care of all of the vector embeddings. And then the agent builder is that higher level service that's going to allow you to compose those ingredients and actually make the application. So this is just a really quick screen grab of, this is actually the demo. Ooh, we're going to do a demo. Okay, yes. So this is going to be a lightning demo. There we go. Are we going? Yes, we're going. Okay. So this is in VCF automation. So after you've gone through the workflow, we're going to go ahead and deploy a model endpoint. You take the URL from the Harbor project. You pick a routing name and a display name. You pick the inference engine, and we're going to keep it simple, no flags or arguments. We're going to give it some GPU compute here, and then give it some storage. We're going to hit next, and you can see the YAML building on the right side. So if you want to version control this, you totally can from an infrastructure as code perspective. Model's up and running. Now we're going to create a knowledge base, which is an envelope within the vector database. So we're going to create a little memory tiering chatbot. We're just going to use some local files here, but like I said, you can connect to different sources of data, and you can create a refresh policy to go and check that source of data for whenever it changes. Next, we have to set some index settings. So these are some kind of data science type settings in terms of how you want the data to be processed and stored in your vector database. So we're going to select our embeddings model, which again runs on the model runtime. We default to sentence splitting. And we're going to configure a chunk size of 200 tokens. So Rama was talking a little bit about tokens previously. Token overlap of 30. Again, that's just a data processing setting you don't need to worry too much about. And once we're done with that, we're going to go ahead and find our little memory tiering PDF here. All right, so we're going to add those local files, hit browse. Nothing special about this part of the process. We've got our little memory tiering PDF there. All right, and then once we hit upload, what we're going to do is we're going to extract the text from the PDFs. We're going to clean it, chunk it, put it in that vector database so it's all ready to go. So now the exciting part happens. We are going to go and build an agent. So we click Create Agent. It's going to be just a little internal product information. We're going to select our model endpoint that we just stood up. If we wanted to be funky and give it some instructions, we could tell the model to talk like a pirate, or we could format the response or something useful like that. In terms of a knowledge base, we're going to click on the memory tiering knowledge base we just made with those PDFs. And then we've got a couple of other settings that we can choose. We can, tell how many chunks we want it to retrieve. 500 is actually kind of a lot. Similarity cutoff is, again, just another guardrail that you can use to police how many chunks are pulled out of the vector database. And then you can do a little bit of session management here. So this might have some performance implications in terms of how the application responds and how much data you're sending over the network. So we're going to ask our question, what is VMware memory tiering? And we're going to get an answer. So again, this is just a very simple little demo here, but if you actually search the internet, you go to Google, you type in VMware memory tiering, there's not a lot of public data about that. So what we've done here is we've, basically loaded in a proprietary little internal playbook on how we want, our data tiering strategy or our memory tiering strategy. And we've created a little chatbot that can help guide infrastructure teams by using our enterprise data. All right. And just to wrap it up here, this is how these services run on your infrastructure. So they run within a workload domain or within a vCenter on top of the supervisor. So once you create your vSphere namespace, you will then, under the covers, VKS cluster or a Kubernetes cluster is what we run the model runtime as. And then our data indexer, our API surface, and our UI all run as pod VMs. So those are photon-based images. DSM, I believe, runs as a VM. Now, the one last thing here, you might say, well, Ash, come on, what are we doing here with NVIDIA? Guess what? You can run NVIDIA NIMs with our model runtime. Now, this is really great because NVIDIA does a lot of work behind the scenes to make their inferencing microservices, NVIDIA Inferencing Microservices, run really efficiently on their infrastructure. So we are in the works of automating those capabilities to make this interplay really nicely with those capabilities, and so that you can make the most of your NVAE investment. And to further highlight this integration, when you go through our quick start guide in VCF automation, these are some of the catalog items that you create. And the three that I've highlighted in green here all use not just the NVIDIA NIMs, but some of the NeMo microservices as well. So these are services that NVIDIA has in their NVAE catalog that also are really great at putting your data to work and creating guardrails to help you monitor the behavior of the applications that you build. You can get started with building with these blueprints. And with that, I will hand it over to Ash.
Okay, cool. Thank you. Okay, so I'm going to take a courageous step. We have a very nice and cozy little room. So I'm going to go wide-free. I've packed enough cup drops, so in case I need it later. But, all right. Okay, so before we discuss NVIDIA AI Enterprise, let's take a quick detour. What you see on the screen is the evolution of AI from an NVIDIA series. And right now, we are somewhere here, just under Jensen, in the throes of what is called agentic AI. What we've noticed in a lot of our customers that you've been speaking with is the fact that organizations across all industry verticals are deeply investing in building out agentic AI capabilities. And we're seeing a growing number of AI agents that are aligned with specific business functions, working with their human counterparts and actually solving interesting customer problems. What's very interesting about agentic AI itself is the approach that an agent takes to solving problems. Unlike single shot AI, which is the predecessor, when you give it a customer problem, the agent will take it, break it down into different steps. Try to reason through every single step, see if it needs to call out to other tools that are internal or external to the organization, even reach out to agents, compute parts of the problem or parts of the solution, put it all together, and then present the eventual solution to the end user. So this planning, reasoning, thinking, and then acting sort of a model is what is going to take me to like one of the takeaways that I want to leave you all with today. With this rise in agentic AI, what we are seeing is an exponential rise in the amount of AI influence across the board. All right, this takes me to the next slide. You must have seen Jensen talk about it earlier this year, but essentially, all of the enterprise data centers that we know of today are undergoing a paradigm shift, aisle by aisle, server by server. Right? We're seeing accelerated compute, networking, and storage come and factor into these data centers. And these data centers are now growing up to become AI factories. My favorite way to sort of think of an AI factory is to think of an end-to-end platform where you're applying your business's proprietary data as well as electricity or power as your materials. And at the output, you get what are called tokens. Tokens are units of intelligence, essentially, and they are directly tied into your organization's outcomes. This could help you get time to market. This would help you create like really superlative customer experiences as well as employee experiences. They directly impact revenue, and therefore they're extremely critical. This takes me to that takeaway number 2, which is going forward, I can actually see every single enterprise, including yours, is going to require an AI factory to manage and manufacture intelligence at scale. All right, this is super exciting for us. For the last several years, NVIDIA has been working with a lot of OEM and ODM partners in the industry to deliver accelerated compute, networking, and storage in the form of purpose-built AI servers. And this is the latest kid on the block. This is the latest AI server to join our fleet of AI servers. This is NVIDIA's RTX Pro server, which brings NVIDIA's Blackwell architecture to the enterprise. Every single RTX Pro server can be configured with up to 8 RTX Pro 6000 Blackwell server GPUs. That's a compromise. But
They're moving your servers. Pretty heavy. Yes.
All right. So this GPU is what we call the universal GPU. And the reason for that is because it delivers universal performance for several different classes of enterprise workloads. You could be churning out visual computing, or you could be doing some numerical data processing, generating some synthetic data, doing a little bit of graphics-enabled applications, running VDI servers, what have you. Any enterprise workload under the sun is going to deliver a great deal of performance on the RTX Pro 6000. Those of you in the audience who are seriously thinking about adding additional AI servers to your existing fleet of GPUs or GPU servers should seriously be considering this one because of its air-cooled form factor and because of the fact that it neatly fits into a 7 kilowatt power, which means that you don't really have to think about introducing changes to your cooling infrastructure. It's just a plug-and-play one. The best part about all of this, NVIDIA and VMware have done all the heavy lifting required to add support for this particular GPU on VCF. This has been done using NVIDIA's virtual GPU technology, which basically means that your platform teams can start adding these GPUs and make it available as a part of your GPU as a service offering to your teams. How exciting! All right, now let's shift gears and talk about NVIDIA AI Enterprise. NVIDIA AI, as we call it, is an end-to-end comprehensive suite of software that accelerates every single layer of the stack. We broadly classify it into 2 buckets. There's infrastructure software and there's application layer software. So at the bottom of this, we are going to see what falls into the infrastructure software layer. We offer you GPU and networking drivers, and we also offer you NVIDIA GPU for compute. All of these artifacts help you to optimize the utilization of GPUs in your watch price requirements. Let's take a quick second to talk about NVIDIA GPU for compute. Say, for example, you have a single physical GPU and you want to carve out different profiles, attach them to multiple different VMs, and make it available to different line businesses for AI inference. That's something that we achieve with NVIDIA GPU for compute. And on the flip side, if you want to attach multiple different GPUs to a single VM, make it available for AI training, that's also something that we can do or accomplish with NVIDIA GPU. We also offer several different Kubernetes operators for you to provision and lifecycle manage basically GPUs and networking resources in enterprise requirements like VCF. We have the GPU operator, the NeMo operator, and the network operator. And going up the stack, you've already heard my colleague here, Pala, as well as if you attended the last presentation, my VMware colleague Shruti talk about NVIDIA NeMo and VMware. The latest kid on this blog is, however, NVIDIA NeMo. So this is our latest open, leading class of multimodal reasoning models that are available. And you saw Rama already start using them as a part of UTS's GPU as a service offering, which is pretty cool for us. All of this software is meant to accelerate all of the different layers of your stack. And the idea is that it helps you get started with the idea of building out generative AI pipelines, as well as agentic AI pipelines, knowing very well that it's going to run on a stable, reliable, industry-leading platform like this. Since we have the time, let's briefly touch upon NeMo. So we launched NVIDIA NeMo at GTC 2024, and since then we've delivered over 170 models, if I'm not wrong, as part of NeMo. And these models map to not just LLMs or large language models, they map to several domains, including visual, RAG, speech, BioNeMo, what have you. The idea behind NeMo, Ala spoke about the core values of Private AI Foundation, right? Simplicity, ease of setup, ability to streamline AI model deployment. That fits neatly into the NeMo value prop. You can take the NeMo, and it contains everything that your AI teams require. Latest AI models, industry standard APIs, prepackaged dependencies, and hardware optimized inference engines. So these are called TRT LLM or TensorRT LLM. So the NeMo itself is a self-contained software container, enterprise grade. You can take it and run it anywhere. And I seriously mean anywhere. On your enterprise data center, on the edge, in your private AI service, or also like the DLVM, the deep learning VM workstation, right? So for example, you could easily grab a NeMo from a GC catalog, like Ala mentioned, put it into your DMZ, make sure it passes all of the sanity checks, upload it to the model store, get it into your model runtime, and boom, you have an inference endpoint setup, easy to use. Because NVIDIA NeMo is offered as part of NVIDIA AI, it is enterprise supported. And what that means essentially is that we do all of the QA, all of the dependency management, security monitoring, CVE mitigation, and all of the automated dependency checks for not just NeMo. This particular outcome actually extends to all of the software that's available, 300 plus software artifacts that are available as a part of NVIDIA AI or NVIDIA AI Enterprise. And obviously, we wouldn't be NVIDIA if we didn't talk about performance, right? I don't have a lot of time, so I'm going to quickly skip through this. But essentially, what this tries to convey is the fact that when you run a NeMo or using its hardware-optimized inference engine, as opposed to an unoptimized model, you can unlock up to 5x improved throughput when it comes to inferencing. What that basically means for platform teams is that you can do 5x the amount of work in the same time, or you can put it another way, you can significantly reduce the amount of hardware that's required to attain the same goal. All right, so we talked about NVIDIA NeMo, we talked about NVIDIA NeMo, and it might be like, all right, what else does NVIDIA have to offer? So what we have learned in our conversations with customers is that as their AI journey starts maturing and they discover more and more use cases that they can address with AI, they want to start deriving value out of their AI investments. That's when you bring your model to your data, right? That's where NVIDIA NeMo comes in. NVIDIA NeMo is an open modular, think of it as an open modular data platform with different microservices that help you to build out your agentic AI workflows every single step of the way. These are all, you can basically cherry pick them. There is absolutely no mandate to go and apply every single microservice that is available as a part of NVIDIA NeMo. And the idea is that you can go one step further and have your AI agents continuously learn from the data and the interactions that they're having with their users. A perfect example to sort of illustrate this would be Rama's AI tutoring agent, right? Rama's team is currently building out an AI tutor agent that will soon be rolled out to different campuses across UT. The next big thing that they could do would possibly be to attach this particular tutor, which is a shared AI service that is rolled out to different campuses with data along with NVIDIA NeMo. And the idea here is that every time there is a student and agent interaction, let's imagine this, right? The student goes into LMS, Learning Management System, talks to the agent, talks to the tutor, asks a question to it. The data that is generated is then fed back into the model and continues to optimize that model over time. So when this happens across different students, multiple interactions, different campuses, the amount of data that is generated and the amount of optimization that is done essentially means that going forward, Rama's team can serve significantly higher number of inference requests and roll out these services across multiple campuses in a shorter time. So there you go, like the ability to sort of gain or drive maximum utilization out of the AI services that you have invested in with NVIDIA NeMo. All right, I'm going to hand it over to Ala to sum this up, but there's one thing that I'll leave you with. VMware announced the Private AI Foundation with NVIDIA roughly 3 years ago, right, Ala? But our engineering partnership extends to over 10 years at this point in time. And with the Private AI Foundation solution with NVIDIA, what we are trying to bring to you is not just disparate products, but a great deal of integration that happens across multiple different layers of the stack so that you all can drive AI outcomes for your enterprise in a way that makes sense to you. So thanks. Over to you, Ala.
Yeah, thanks, Ash. All right, hopefully I won't kill the slides again. All right, so yeah, to just wrap it up again, what we hope you've taken away from this talk today is the art of the possible with our integrated platform. So how can you take this and roll this out to your lines of business, to your end customers, if you're a cloud service provider, and to make these capabilities available as a service for your various use cases. So to just sum it up, we've done a ton of work with NVIDIA to enable their NVAE services. NVIDIA, of course, includes vGPU, which we deeply integrate with from a virtualization standpoint to allow for that GPU segmentation so that you can drive high utilization of your GPUs. And then this middle package here is all of the capabilities that now come with VCF, whether it's that application and developer experience to build those GenAI applications, combined with the goodness of our virtualization capabilities with DRS and GPU monitoring and the good hardened workload security that you get with ESXi. So please take your survey, enjoy the rest of the show, and yeah, we are now open for questions.
Yeah, go ahead.
So you just touched on the optimizations that you've done around GPUs. Can you kind of maybe touch on a couple of the aspects, like the VCF9 world and some of the optimizations that we have today, but like maybe for clients that have looked at doing this in the past and maybe in the past maybe not being so optimized, what does that really look like in VCF9 as compared to the past, and like even down to like VM stun times, vMotion?
Oh, I wish I had a backup slide for that. So you touched on something that's probably near and dear to all our hearts, which is vMotion. So we did some really exciting engineering in the VCF9 release to really separate out in the pre-copy phase dirty versus, or it's like hot cold versus cold data. So what we've been able to do, which I believe this may have been touched on in the keynote, is to drastically reduce the stun time of GPU-enabled VMs, just because that memory is so heavy compared to traditional workloads. So I guess this is a really good example of some co-engineering that we've been able to do at the virtualization layer to really tease out sort of what bits of data do we need in the pre-copy phase versus what we can wait to actually copy over at a later time. So we've, like, the reduction is from like a 20-second stun time to like less than 1 second. So that's really exciting. Now, we have integrated for several years with the vGPU construct, both whether you're using MIG or time slicing. But I think, you know, something that's really exciting is really the evolutions in our tenancy model. So as many of you may be aware, in VCF9, what we've done is we've started to migrate the VCD, or VMware Cloud Director APIs, directly into VCF automation. So this is going to allow you to, again, just give you a lot of different choices to sort of how you want to segregate your GPUs. Do you want to do it at a cluster, you know, a physical cluster level, or even if you just have a shared GPU, let's say you want to slice it up into 7 MIG slices. You can make, you know, those any of those slices available to different tenants in your organization. Now you probably want to do that with more than just one GPU with a whole cluster. Of course, but I think that that's another really exciting way that we've been able to match like some of the lower level virtualization capabilities that we're investing in with some of the higher level like automation and tenancy capabilities. One other thing that we're also collaborating on together is also enabling some of the smart NICs with our networking stack as well. So we're, for folks who might be like really familiar with ESXi, we have a set of APIs APIs. They're called our DVX APIs. And so this is going to allow you to vMotion and apply DRS to those workloads. So typically you would have had to have run those NICs and pass-through previously, but that's work that's ongoing collaboration right now. So we're really excited about that.
With sharing the GPU, like in a multi-tenancy model, obviously, like, they're expensive, right? So being able to utilize those more frequently, that was probably like paramount to that effort.
Exactly.
Also, security was paramount to that effort, so that one tenant can't see another GPU.
Exactly. So, I mean, that really depends. Like, I was talking to a defense customer several months ago, and, this is where you have to decide based on your use case. Do you need that, this cluster is only for, like, this customer or this line of business? Because they were telling me about a use case where they have to have a 30-minute, like dead period after they completely clear the memory out of their GPU before they can schedule anything else, like even from, like, the same team in the same organization, because their use case is so locked down. So it just really depends. Like, some people are like, yeah, tenancy with time slicing is fine, but then you have, like, really confidential use cases where it's like, we need to chill out for an hour and like really make sure that the data is clear from memory. So it depends.
Just to add on to that, right? Just to add a bit more color, when you use outcomes like MIG, say for example, MIG-back vGPUs or MIG-back vGPU VMs, the idea is that you're spatially partitioning the vGPU or the GPU itself, creating MIG instances, and every single MIG has its own streaming multiprocessors. So there is no chance that a process that is running on one part is going to interfere or bleed into another part of, like, that particular GPU itself or into another GPU instance. So that's how we maintain these spatial boundaries so that every single workload that's running side by side receives the same QoS and doesn't impact or go beyond security boundaries in a way. So, yeah.
Just to follow up on that, through VCF, can use MIG.
Yes, you can.
MIG and time slicing, we support both.
But I have a question. So how are we helping the private AI, helping the business case right now? As you know, most AI initiatives, proof of concepts, fail with 70, I think 90%, right?
I think, did everyone read that MIT paper that came out? Yeah.
So how are you helping that piece? Because I think you see it with our clients.
Totally. And I was talking to a customer this weekend who said, you can set a 3-year timer on any new technology. And it's like the innovation teams are like, we got to run it bare metal and we're going to do it all ourselves. And then it takes them 3 years to get tired. And they're like, they come to central IT, they're like, we're tired. Can you help us? So I think, what our solution does a really good job of, similar to your question, is is sort of allowing for disciplined, thoughtful experimentation. Instead of just, handing the innovation teams a credit card to go experiment in the cloud, if you have GPUs on-prem, you're able to carve out sandboxes, and you're able to say, okay, here's a set of services, or, if you have NVAE licenses, like here's some options for creating an application, but this is your infrastructure sandbox. And if you need more later, come and get us. But you're not, the likelihood of you making a $500,000 mistake because there was some data query that was left running on AWS, which I have an $800 mistake of when I was doing some experimentation myself, is really decreased. So I would say what private AI on VCF allows you to do is just that disciplined experimentation. But I would also say that, this is something that I think we could partner with really well. I think we were talking about this at dinner last night. How do you, what is the checklist? What makes a successful experiment? And the answer, just to be really, really short and sweet here, have a specific problem you want to solve. Make it, yes, okay. he's a member of Rama Teams. But you guys got started with an HR training chatbot. Look for a basic back office internal problem and keep it simple. Don't try to go agentic MCP server for your first application. Start with something small, find a small model, the small models are doing great, they're kicking butt for individual use cases. So disciplined infrastructure, experimentation environment is step obviously step 0. And then step 1 is really, if your teams come to you asking for that, be like, what is your use case? Like, what problem are you trying to solve?
And I think it's helpful, especially for the private AI, right? It's the security, right? Because you guys see some, right? That is going to say, I don't want anything in the cloud, right?
Mhm.
So it's
Right.
better to have.
Totally.
Yeah.
Yeah.
Thank you.
All right.
Thank you.
Thank you all for coming.
Yeah.
Thanks, everyone.
Appreciate it.